Okay, so the next lesson is going to be the area of circles and sector area. Our last lesson was over circumference and arc length, and so now we're moving into the area and sector area part. So let's start with area. It is going to be the most familiar to you, and I'm not going to spend time reviewing vocabulary like radius and diameter and how you define a circle because we did that in the last video. I'm going to go ahead and jump into the formula. So the area of a circle with radius r is a equals pi r squared. Now notice that this is different from the circumference formula. Number one, because there's a squared, but also notice that there's no diameter option. So if you want to be able to find the area of a circle, you have to know what the radius is. But luckily we already know that the radius is half of the diameter. So if all I'm given is the diameter, all I have to do is divide the diameter in 2. Because there's no more vocabulary, let's go ahead and go into an example. I'm going to go ahead and write it down, and then you pause the video and copy before you start trying to do the work. The first example is find the area of circle K in terms of pi. And there's my circle. I know it's circle K because that center point is labeled as K. Now, this is actually the exact same circle that we used on our circumference notes. The only difference is this time it's asking us to find the area. But if you notice, our area formula again says A equals pi r squared, and unfortunately we don't have an r, we don't have a radius, we only have a diameter of 6 inches. But if I want to find the radius, all I have to do is divide that by 2, which tells me that my radius is 3 inches. And I can use that 3 and substitute it into my formula. So A equals pi times 3 squared. And 3 squared, as we know, is 9. And I want to leave the pi alone because it says in terms of pi, which is really nice for me. I don't have to worry about any sort of decimal answers. So A equals 9 pi, but of course you need units. So I'm going to say inches squared. And that part is very important, that you say that it is inches squared, not just inches, because this is not a length, it is an area, which means I need square units. And that's how you find area of a circle. And I went through that kind of quickly because you've already done it before. The next part, however, is what's new to you, which is a sector of a circle. Now, sector of a circle is very similar to arc length in that it represents a fraction of the area, just like arc length represents a fraction of the circumference. So the sector of a circle is a region bound, so it's a region, it's a shaded area, bound by 2 radii, and radii is just plural for radius of the circle, and their intercepted arc. Now when I draw a diagram, this is going to make way more sense, okay? So, sector of a circle, that's that formula. So I've got my circle, I've got a center, I've got 2 radii. I'm going to label the intersection point A and B. Now, back whenever we had arc length, we cared about that measure right there. We cared about the length of that measure. But now we are still going to use that measure, that angle measure, but we don't care about the length of that arc anymore. We care about that shaded area right there, that region that is bounded by those 2 radii. Oops, I forgot to give my circle a name. So this right here is the region, this is called the sector ACB, very similar to how you label an angle. So the formula is, just like it's a arc length was a fraction of the circumference, this is again a fraction of the area. So I need the area, which is pi r squared, multiplied by measure of that arc divided by total degrees in a circle, which is 360. And that's all it is to find the sector of to find the area of the sector of a circle. So let's go ahead and jump in and do a couple of examples. I don't think it'll be too problematic for you guys. So again, I'm going to write the example down. You pause the video and copy it, and then we'll do the examples together. So these are the two examples that we're going to do. Again, pause the video and copy down these two examples. So the first example says find the area, let's read all the directions first. Find the area of each sector, give the answer in terms of pi, and round it to the nearest hundredth. So I'm giving two answers for each example, one in terms of pi and then one as a decimal answer. So first I'm going to start with my formula like always. A equals pi r squared times measure of the arc divided by 360. Okay, so, So I've got sector BAC, which is why it's this shaded area right here. So I have A equals pi times my radius, which is 6 centimeters squared, times that arc measure is 45 degrees out of a total of 360. Now, when you're leaving it in terms of pi, you're just going to type this part into your calculator or do it in your head or however you want to do it. But then you're just going to bring that pi down into your final answer. So whenever you do this, you could get a decimal answer. Go ahead and write it down. Go ahead and calculate it and write it down and see if your answer matches mine. If you leave it as a decimal, you'll get 4.5. And then, of course, you have to bring down your pi. And again, since it's area, you do need squared units. So centimeters squared. Or you could write it as a fraction and say area equals 9/2 pi centimeters squared. That is my answer whenever it says in terms of pi. But it also says rounded to the nearest hundredth. So all I have to do is type this straight into my calculator. Now, you don't want to do 4.5 times 3.14. That's not accurate, and that is something that you would do if it specifically said use 3.14. If it doesn't say use 3.14, you need to use the pi button on your calculator, which would be second, and then the button that's right underneath the clear key. And so whenever you do that, you get an answer of it is 137, but because I want it to the nearest hundredth, I'm just going to say 14.14 centimeters squared, and I really shouldn't even put equals. I need to say approximately. So this right here is my answer in terms of pi, and this right here is my answer rounded to the nearest hundredth. Same thing for the second example. What I want you to do right now is pause the video and go try it on your own. Well, you can only try it on your own if I give you that radius, which is 8 feet. Okay, so pause the video right now. If you haven't copied it down, copy it down, and then try to do the whole thing on your own, and then unpause and see if you get the same answer that I do. So if you did it right, you would have done A equals pi r squared times m, measure of the arc, over 360. So area equals pi times my radius, which is 8 feet squared, times that measure of that angle, or measure of that arc is 120 degrees, divided by 360 degrees. When you leave your answer in terms of pi, you get like 21.333333, which of course we're smarter than that than to write repeating decimals. So you can write 21 1/3 pi feet squared. Or you can write area is equal to 64/3 pi feet squared. That's you leaving your answer in terms of pi. To write my answer to the nearest 100th, I'm going to type that into my calculator, and I get 67.02 feet squared. And that's how you find the sector area of a circle.